Okay, section 4, the examples. I'll go through the examples. And this is to reinforce what was being taught in the lecture or presented to you in the lecture. So I'm going to switch to the whiteboard. Give me 1 second to do so. And we'll do one problem at a time. So the first problem says find the volume of solid. Of the solid whose cross sections perpendicular to the x-axis are rectangles. All right, so let's put this down. And again, try to visualize here. Find the volume of solid intersection. Oh, there's a picture. Let me go to that. And this is the picture over here. So let's take a look at that. And my understanding looking at the picture is to understand that it relates to an integration somewhere. And I kind of partially see what they're talking about over here. Let me draw this in for you. And I'm going to put a little box here for you. Now, when I do that, I'm starting to realize it's going along the x-axis. So the integration, from looking at it, appears to start at 0 and ends at 3. And this is along the x-axis dx. All right, so I got the dx part down. The next thing I want to do is I want to get this dimension over here. And this dimension is 2.5, which is 5/2. And again, I'm getting the box. All right, now here comes the tough part. So I have the dimension. I'll point out I have the width of it. I have this dimension, but I don't have the height of it. The height of it's related to this line over here, and it changes. So I need to find out what the equation of that line is. So the equation of this line over here is y equals, well, it has a negative slope. And what's that slope going to be? Well, it looks like the rise is -2 and the run is 3. X plus the y-intercept appears to be 2. So write that down. Okay, what are we going to do now? I can make time to integrate it. I'll look at the key later, by the way. Part of doing that is just simply, simplifying the integrand. And what do you get over there? -10. That would be x. And 2 times 3. You know what? Let me just reduce that. That's crazy, right? That what I just did. Get my eraser out. And that would be -5/3. Plus 5 dx. Integrate, -5/3. And it's going to be x squared. So 3 times 2 is 6. Plus 5x. Limits of integration will be 0 to 3. -5, 6. 3 squared is 9. Plus 15. I'll do the trick later. Whoops, made a mistake already. Someone said, how do you know you made a mistake? I'm looking at my work. And you should be looking at your work too and be careful and critical of it as well. And then -0. And what do you get there? Let's see. I'd reduce it. So 3, right? So it's going to be 2. And then 3 -15 plus 15, which turns out to be 15/2. All right, I'm going to go back to the key. And I'm seeing it. All right, I'm also seeing the integration written down like this. Okay, let's go to number 2 now. And again, it's find a volume of solid cross section. And they give me a picture over here. So let's look at the picture. And this is the picture you're talking about over here. And again, a little more challenging. By the way, the pictures aren't great. I kind of lifted these out of a book, but they're better than I could have done. I'll be honest with you. So I'm going to just simply, I see something here. I see this thing over here, which I know is the half of like a disc, so to speak. All right. So what's the integration going to be? Well, kind of looking at it, it looks like it starts at 0 and stops at 3 along the x-axis dx. All right, I got a problem now. My problem is, visualizing this thing over here, and I'm kind of looking at it, and again, a little dizzy looking at it actually. But I get an idea of what's going on over here. I see the line. It's going up to 1. Not a really pretty bad picture, isn't it? Anyway, I can put this over here. So that line, y equals, well, looks like the rise is 1 and the run is 3, x, and the y-intercept is 0. That's 1/3 of an x. My issue over here is that I have to realize it's related to this object over here, which is the half of a disk. And what's the surface area of that? Well, it's half of a disk. The surface area would be, again, I'm looking at, let me outline that for you. I'm looking at the surface area, this thing here. That would be 1/2 pi r squared, right? Well, the r squared, if you think about it, is just the height of that object. All right, so radius of the object, which is 1/3 of an x. Right, it varies over the interval between 0 and 3 is 1/3 of x. Right? So I think I have it now. Let's write this down. 1/2 pi r squared. What's my objective here? Simplify the integrand. And what do you get? Pi comes out. You get 9 times 2, which is 18. X squared dx. Fairly easy to do. Also easy to make mistakes. That's going to be x cubed over 3, 0 to 3. That's going to be pi over 18. Well, that'd be, 3 cubed over 3 is really just 9, right? Minus 0. Pretty easy to do. It's also pretty easy to make mistakes, by the way. So pi over 2. And that's going to be cubic units. Let's go back, see how we did. Okay, I'm seeing it. Let me make sure I did that page. The next page. And number 3. Number 3 says let f of x equal the square root of x. Find the value c in the interval between 5 and 14 such that fc is equal to the average of f on 5 to 14. So I want to do f average first. Whoops. Well, what's that going to be? Well, I went too quick there. 1 over, 5 and 14, so it's 14 minus 5. And it's going to be from 5 to 14. F of x, which is x to the 1/2, dx. Got to do it. And again, not beyond making mistakes. That's why we have a key for you. That's 1/11th. Right, because 14 minus 5 is, oh, I'm sorry, 1/9. What am I saying? Now, people make mistakes, but you want to try to clarify those mistakes by correcting them. All right, what do you get over here? X to the 3/2. Now, divided by 3 is like multiplied by 2/3. Integration can be 5 to 14. I look at nasty numbers, but I got to do it. And what are you going to get over here? Well, it's going to be 2 27s. And that's going to be, let's see, it's going to be 14 root 14 minus 5 root 5. All right, that's the average value. Again, let's go read it where they say, you want to find the number c on the interval between 5 and 14 such that f of c, whoops, is equal to f average. Again, it looks challenging for me. I think I made a mistake in the penmanship over here. Let me clean it up. Let's write this down. What's f? Well, square root. The square root of c is equal to, let's write this down, 2 27s. This is the average value, by the way. 14 root 14 minus 5 root 5. And what would c equal? Well, I got to do this. And someone says, what do you mean you got to do it? I got to write it down. 2 squared, 14 root 14 minus 5 root 5 squared over 27 squared. Now, granted, something can say, I wonder if that's correct. You got to be honest with that. That's a good question. Is it correct? I'll look at the key, and certainly I'm seeing 2 squared, 27 squared, 4 root 14. Yeah, look, I did okay. By the way, this is completely acceptable on the exams. I'm doubting Thomas, though. What I would recommend you do is, do a computation on a computer, get this number, clearly it's a number between 5 and 14. If you want, you can simplify these guys. don't feel obligated to do so. So if you want to simplify, please do so. All right. Thank you for paying attention. Again, if you have any concerns about what's presented to you, please come by during office hours and I'll help you with it.